Hello, Mr. Witherow here. We're going to talk about distributive property today, along with combining like terms. And we're going to add the element of algebra to this with those exponents. Now, we just got done talking about exponents and understanding that when we have multiplication, we add the exponents, right? So when we have this basic, these first couple ones are pretty basic. We take the 8 and we distribute it to all the numbers on all the things on the inside. So 8 times x is 8x, and 8 times 7 is 56, and we're done. We don't get to combining the like terms because the x term and the constant, so we're done. And number 2 is exactly the same way. So 4 times 3 is 12x, and 4 times 2 is 8, and we're done. We don't have to do anything with that. But now, starting with number 3, we start getting into there's a variable on the outside here. So now we have to distribute this variable to everybody on the inside. So we have to remember that x times x, which is what this is, we would then add the exponents. And my little saying, if I don't see 1, it is 1. So there's an exponent here of 1, and there's an exponent here of 1. So x times x is really x to the 1 plus 1, or 2. So x times x is x squared, and then x times 6 is 6x. Remember, writing this means that we always put the coefficient first, or the number first, and then the variable. This means multiplication. We don't have to put a dot. We don't have to put the x. We just put them together, squish them together, 6x, and you're done. These are not the same term, even though they both have x's in them. This is an x squared term, and this is just an x term. So we're done with this problem. So then if we drop down to number 5, now we're going to take this 5x and we're going to multiply it by everybody here. And remember, we stop here. This plus x is not inside the parentheses. So this 5x is only going to be multiplied by the 3x and the 1. So 5x times 3x, we multiply the coefficients, or the big numbers, and we add the exponents. So 5 times 3 is 15, and x times x is x squared. And then 5x times 1 is just 5x. And then we add this to it, plus x squared. And now we have to ask ourselves, can we combine these things? Is there any terms that we can put together? And sure enough, we have 15x squareds, and we have another x squared. So how many x squareds do we have together? 15 plus 1 is 16. So now we're at 16x squareds, and we don't have a partner for the 5x, so we just simply write down 5x, and we're done. Be sure to understand the fact that when you're multiplying x times x, you're going to get x squared, which is a different term than just x. So then you're going to finish these down here. Now, the other cool one is this thing called FOIL. FOIL stands for first, outside, inside, and last. And they're talking about terms here. All right? So the first, outside, inside, last terms. When we have two binomials, which means that there's two terms, and we're multiplying them together, we're really doing a double distribution, sort of like this up here, but we're now going to take the x, and we're going to take the x and multiply it by the x. Notice that these are the first terms inside the parentheses. That's where the f comes from. And then we want the last terms, which are the outside terms. So that's here, outside terms. Then we want the inside terms. So we're going to distribute the 2. So we distribute the x to the x, and then the x to the 3, and then the 2 to the x, and then the 2 to the 3, which is the last terms. So here we would have x times x, which is x squared. That's my first. X times 3 is 3x. That's my outside. 2 times x is 2x. That's my inside. And 2 times 3, which is my 6, which is my last. So FOIL, F-O-I-L, first, outside, inside, last. Notice that these two terms we're going to be able to combine. So we would have x squared, then 3x plus 2x is 5x. We don't do anything with the exponents. And then we have plus 6. So this would be my answer. Now, some of you are like, oh, wow, that's really different, and how do we do that? Well, is there a different way we can do the same problem? And yes, there's a different way you can do that same problem. You don't have to follow the FOIL. You can do the box method, all right? Some of us know the box method. So since there are two terms here, x plus 2 and x plus 3, then I simply make a box, a 2 by 2 box, all right? I put x, 2, x, 3. And now I just simply multiply, right? So x times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. So now what we look at is that we look at diagonally, we can combine these two terms. So we would always put the x squared first. 3x plus 2x is 5x. And then we put the constant last. So this is the same as this up here. Look at that. Same way. Two different ways to do the problem, FOIL and box. It doesn't matter which way you use it. I know the directions say FOIL, but you can certainly use box as well. All right, the biggest thing you have to understand is that you're probably more than likely going to get 3 terms. Sometimes you don't, right? Sometimes you don't. If you notice down here, I'm willing to bet that you don't get 3 terms. One of the terms is going to disappear. That middle term is going to disappear. All right, give it a shot. See if I'm right. All right, that'll do. Have fun.